I'm gonna work example 16.6 for you. Okay, we have a rigid body, a member AB, that is fixed by these collars that go in this guided path. So as A moves down, B is going to go to the right. And as a result, we're going to have some omega also, or angular velocity about the rod AB. And we're going to figure out if we know that the velocity of A is a negative 2 meters per second in the J direction. So the collar up here at A is moving down. Whenever these angles right here get to 45 degrees, what's the velocity of B? Alright, so we're going to say, what's the velocity of B? We know the velocity of A, that's our translating motion, and velocity of B with respect to A is going to be our rotational motion. So let's turn this into the velocity of B is equal to the velocity of A plus omega crossed R of B with respect to A. Okay, we need this. We need our position vector. How do we describe B with respect to A? We know the distance is 0.2 meters, and we know the angle of interest is 45, so I'm going to get a 0.2 sine 45 in the I direction plus a negative 0.2 cosine of 45 in the J direction. Alright, we are actually going to take this cross product. Our omega, we're just going to give it a K direction, because if I and J are taken, then it is going to rotate using your hand, rotating with omega, it'll rotate out of the page in the K direction. So let's fill this stuff in. We want the velocity of B. Well, we know, here's a big key point for all these problems. Sometimes the motion will be constrained at one point or both, and in this case it's constrained to move only vertically at A, and it's constrained to move only horizontally at B. So I'm going to tag a velocity of B in the I direction onto it, because B has to be moving in the I direction. Alright, we know the velocity of A is a negative 2 in the J. And then we need to do a cross product with omega k crossed into our position vector that we just came up with. 0.2 sine 45 in the I direction plus 0.2 cosine 45 in the J. Alright, excuse me. The velocity of B in the I direction, taking it another step. Just copy the component of the velocity of B back down, and now let's take the cross products. K crossed into I will give us J, so it's going to give me 0.2 times omega, and it's going to be in the J direction, and that's for that right there. Okay, now omega k crossed into this term, k crossed into J, I, J, K. K crossed into J will give us a minus I. So I get a negative 0.2. I think I should have a positive. Hold on, let me check. Yeah, it should be positive. Okay, so 0.2 omega times the cosine. Nope, I'm leaving terms out, y'all. I'm sorry. So I need the magnitude of this and the magnitude of this. So I need the cosine, the sine of 45. And k crossed into I. Let's make our little thing again. K crossed into I will give us a positive j. Alright, for this term crossed into this term, k crossed into j, should give me a minus I. I have a positive for some reason. I'm going to use a minus, then we get the 0.2 cosine 45 times omega in the I direction. Alright, so we don't know the velocity of b and we don't know omega, but we can create two equations. So we'll do this by equating I and j and k components. And I like doing this by just drawing boxes. So we have an I component and an I component. We have a j component and a j component. So let's make two equations. Let's do the I in orange. I get the velocity of b is equal to, you can drop the I, 0.2 omega cosine 45 degrees. Well, we still need another equation. There's two unknowns. But if I equate the j terms, I'll get a negative 2 0 is equal to negative 2 plus 0.2 omega sine 45. Alright, so equation 1, equation 2, we got everything we need now. Change color again. Omega should come out as positive 14.1 radians per second. And the velocity of b will then be 2 meters per second. And we know it's going to the right, so give it a positive j. I'm trying to figure out where... Oh, I get it. I should have had a minus sign right here, y'all, for my sine component. I measured the y component as 0.2 sine 45. Should be a minus 0.2 sine 45. So this will end up being positive. And when you solve that, you will then get positive answers. Correct. Alright, there we go. Glad I found my mistake. I wouldn't have made this mistake if I would have measured all of my angles from the positive x-axis, and I just went against what I always teach myself. So even if it's an angle like this, where that's 45 and this is 45, you can hold on to the sine by calling it, dang it, 360 minus 45. Alright, thank y'all.